Hello everyone, I'm glad to be here today to show you my topic. I hope you like it. And without further ado, let's go. I'm going to be speaking about the evaluation of the socio-affective competence using unplugged tasks to work around computational thinking in the mathematics education. I'm pretty sure the title could say everything, and I could just leave the rest of the 20 minutes for questions, but I feel like it's more important to explain a little bit more what we are trying to achieve with our tools. So here we go. When we speak about socio-affective competence, we speak about something that has been included in our Spanish educational law, and I'm pretty sure that it has been included in many other laws from the European Union and many other countries, uh, maybe with different names. And here we try to deal with the psychological aspects of mathematics, both the intrapersonal, we'll talk about that later, and the interpersonal, again, we'll talk about it later. How we perceive mathematics, how we behave around mathematics, and how we fear, in most of the cases, this subject. But also how we behave around others, how we respect their decisions, and how we communicate with others. Those are the two main aspects of the socio-affective competence. And of course, they form a key role in mathematics learning. Authors like Alsina uh, give a lot of importance to it. But of course, one might say, okay, now we need to begin a new branch of knowledge in mathematics education or in education in general. That could be any further from the truth. We have something called emotional intelligence, which speaks about this socio-affective competence in quite a great detail. We have some of the more inclined people to talk about it, like Goldman, like Baron, and from these authors, we have taken these 5 aspects of the emotional intelligence that we take into consideration when teaching to kids. The first 3 of them go into the intrapersonal, into the oneself, which are emotional conscience, self-awareness, pretty much, emotional management, as I say there, self-control, and motivation. If you're inclined to do an activity, you learn better. The same way, if you know how to deal with a task, how to deal with some content, you learn better. Then with the interpersonal aspects, we have to differentiate between empathy, which is understanding others, and social abilities, knowing how to speak, when to speak, and who to speak. Of course, there's a wide range of work behind the emotional intelligence, and especially in mathematics, because of course this is one of the subjects that our students fear the most, which means that a lot of authors have already spoken about it. The thing is that we have already dealt a lot with socio-affective competence, we just named it differently. But of course, if we teach with traditional methodology, it would be hard for us to develop this socio-affective competence the way that we want. So we need to be in search of an active methodology that could work well for us. The best option for us was game-based learning, as we can see there, and we can see some sprinkles of gamification as well. But if we had to explain what game-based learning is, in short, is pretty much using games with a learning outcome. It could be board games, it could be video games, computer games, it doesn't matter. When dealing with games as a learning outcome, we need to focus on one of 3 paradigms. We could try and work with all of them, but if we focus on one of them, it's the best that we can do. The paradigms of games, as some authors have discussed, uh, depend on whether you want to work or learn from technology. By technology, we mean the games themselves, with technology or in technology. When we work from technology, we just use games as interventions. They are pretty secondary, and we care about the learning, about the ideas that we need to teach them. When we work with technologies, the games are interactive tools that play a big role into the learning. It doesn't matter what to use with them. We just use the games as the tools themselves, and we focus on that. But we prefer to work in technology, which is working with technology, but in a context, in a very rich context. As the word says, this is enriching for the kids because they can learn not only, for example, mathematics, but also mathematics with some history, mathematics with PE, with physical education, etc., etc. It's the way, it's the paradigm that we try to go for when teaching with this in this experience. Of course, there's a lot of work surrounding game-based learning in mathematics, and especially when dealing with emotions, when dealing with emotional intelligence and the socio-affective aspect. So it makes it interesting, and it makes sense to work around this active methodology. Another of the aspects that we needed to take into consideration was computational thinking, which, as we can see in that map, which I don't know where my wobbly head would be, but I'm thinking to put it right above, so it's down here. In this case, we have computational thinking as something included into the educational law, which you can see below how so. In Spain, particularly, it has been included in mathematics and technology. So we need to know how to characterize it well to teach mathematics with it, or to teach mathematics in it. As the text says right there, computational thinking has many definitions, but the one I wrote there is the more the one that we accept the most, which is just setting a set of tasks, of problems that can be resolved in a way that we teach an information processing agent to do something. By information processing agent, we can consider a computer, but we can also consider something that doesn't have to do with a computer. That's why we deal with what is called unplugged tasks for computational thinking, which is just computational thinking without using a computer. This branch of thought, computational thinking, is quite recent. Well, not as recent, but we haven't begun working around it until 2006 with Janet Wings's paper. And we would have thought that it was really clear what we had to do, but in reality, we have shifted in so many ways that it's really difficult to define not only the term, but also see what skills we can use. In this slide, we can see a bunch of them, like decomposition, which is just dividing a problem into smaller and easier problems. Algorithmic thinking, which is just the process of an algorithm or around it. Abstraction, which is just take an idea and make it not depend on the materials that we have. Debugging, which is just testing and debugging, which it could be an algorithm, a program, a result, to see if it is correct, and if it's not correct, just smallly but surely change it to improve it. Automation, which is just kind of similar to repetition, but not exactly. This one is the more unsure that we have. And generalization is just, we have a result previously, so we can take it into something else. In mathematics, generalization and abstraction are not the same. The generalization, in our case, in mathematics sense, it would be analogy, just to take into consideration. Research on computational thinking has been quite recent, as I've said, 2006 onwards, but it has grown exponentially, especially now since the law requires us to see computational thinking. And so there are a lot of reference both in the US, in China, and in here in Spain, we also have some reference to work around. But what have we done to work around all of this that we have explained? Well, our investigation is part of a bigger project where we try to promote computational thinking through unplugged activities, in which we try to test the waters into this socio-affective aspect to see how kids react to the activities, how they work in groups, and how they learn this computational thinking. By doing so, I don't know where my wobbly head would be. I'm pretty sure I'm gonna leave down the table and also the pieces that we use. This game below is called Turing Tumble, and it's a game, a board game that simulates a chip and let us create roads. It let us create algorithms that make those little marbles go into red, blue, etc., etc. With this, we try to make a qualitative investigation. This is just a pilotage of a bigger design that we have already improved because this has been a long time ago. And we use a sample of 6 girls, which are 9 to 10-year-old. They were chosen through availability. It was just a small little thing. And we just designed 6 tasks that offer different ideas. But that's not the important part. The important part comes now with how do we evaluate that socio-affective aspect. To do so, we created this instrument of evaluation, taking into consideration those 5 points of Goldman, and also some more tests that the ECI and many others that have so many points to take into consideration, and also are not free, they cost money. So we try to create an instrument of evaluation that is a bit smaller, that it costs no money, and we did just this to begin in order for us to improve at some point the instrument and validate it at some point. We just try to test if this could work with our evaluation. Again, we point this with a level from 1 to 4, as we can see below. It goes from rarely to usually, and we tested through every single girl. They were put in pairs, but we tested through every single one of them individually. By doing so, we created this table of results in which I'm pretty sure we can see pretty well what we are trying to show. Just to talk about a little bit anecdotically, more so, we can divide the groups into 3 interventions and 3 experiences, because all of those 3 pairs gave us different experiences. Alma and Mia had the chance that they knew a little bit of programming, and Alma in fact knew about the machine, so she was pretty she knew how to use the machine. In this case, they both had strong individual intelligences, as we can see. They were really easy to read the instructions, to work around them and solve them pretty well, but they lack a little bit in that teamwork. Alma, since she knew how to use the machine, she was more individual. She was doing everything by herself, whereas Mia tried to work more in groups, being more receptive, but it didn't work out in the end, making the experience a little bit more individual by their parts. Eva and Anna, on the other hand, had really great group intelligence, interpersonal intelligence. As we can see, they work around each other really well. They didn't frustrate each other or themselves when dealing with the activities. But in the intrapersonal intelligence, they were more scared on how to deal with the next activity on a difficult task, or even when they finished an activity, they would always seek validation by looking at the adult when they were when they were finishing the task and when they were reading or doing something. So it's true that they had strong interpersonal intelligence, but not so strong intrapersonal intelligence. They still, as we can see below, did the best out of all of them. We'll explain the other table later. In the end, we have Sara and Maria, which had a clash of intelligences. Sara was more individual, whereas Maria was more receptive and wanted to work more in groups. So one had more intrapersonal intelligence, the other one had more interpersonal intelligence. that created a problem. They didn't know how to solve some problems. They got stuck more often, and as we can see there, they never asked for help, either because Sara was too proud of herself to do so, or because Maria was too scared to say otherwise. This class, as we can see below, affected into the level of activities. I'm going to explain that table right now. The table below shows each task and the level of efficiency that they showed. High being a high efficiency, medium being a medium efficiency, and then low, it doesn't appear there. All of the results were kind of all right. Low efficiency. Alma and Mia had problems with only one task. Eva and Anna had no problem with any of them. And Sara and Maria were the one who struggled the most. All of these experiences were taken into consideration with recordings. We recorded them with the permission of their parents, and the results were analyzed later. That's how we could take those results little by little. We checked how often those skills were found in the videos, and that's how we show that they were more often, more rare. This was used for a bigger project. We need to get a bigger sample, a larger sample. We need to improve on the activities because, of course, there were just 6 activities, and it was our first time testing with these activities. And of course, we needed to improve and validate the tool, which is what we are trying to do right now. That is the work that we are doing at the moment. In fact, all of these experiences have been already done. We just need to share it with the world, and we don't have time to do everything that we would like to do. With nothing else, this is it. This is pretty much our work. This is framed, as we say there in the project, with that code, financed by the Plan Propio de Investigación, Transferencia y Divulgación Científica from the University of Málaga, and the group of investigation that has worked with it is 324, which roughly translates to investigation in the functional, formative, and instrumental character of the didactic of mathematics. I hope you have a great time. If you have any questions, I'm sorry, I won't be able to answer them. But I hope you like this, and hopefully you learn something more. Thank you very much.